All right, so Module 5.4, you spent today looking at some graphs and what things do and how things change. Today we're going to talk about sketching the graph of a polynomial function. Okay, the word sketch means it's not exact, but it's close. It has key components such as x-intercept, correct ends and middles, which means we need to know what's happening in between those x-intercepts, and we need to know what happens on the ends of our function. All of our polynomials are going to be given to us, I believe, in factored form. So the first thing we have to do is identify what those x-intercepts are. Now, to do that in factored form, it's pretty basic. We are going to use that zero product property, which means we're going to take each of our factors, and in this case, this is example 1, we're going to take the x plus 2, and x minus 3. And we're going to set each of those factors equal to 0. Well, we get x equals 0, x plus 2 equals 0, and x minus 3 equals 0. We're going to solve each for x. This one's already done, so this becomes x equals negative 2, and this is x equals positive 3. Those are our three intercepts. Those are where it crosses the x-axis. So we have a point at 0, we have one at negative 2, and another one at positive 3. So we find our x-intercepts, then we graph those points. And they're always graphed on the x-axis. Now, we need to figure out what our graph is doing in between. And so we need to look at this and go, all right, so we need to figure out what our graph is doing before negative 2. And we really don't care so much about the answers that we get. We just want to know if they're positive or negative. So pick a number to the left of negative 2, such as negative 3. And I'm going to plug it in. I get negative 3. Negative 3 plus 2, negative 3, minus 3. And I just want to find out, is that number going to be positive or negative? So get out your calculators, make life a little easy. So it's negative 3 times negative 1 times negative 6. Well, these numbers are easy because 3 times 1 is 3 times 6 is 18. And then a negative times a negative is positive times a negative is negative. So I don't care that it's 18. All I care about is negative, which means when this is here, this is like way down here. So I'm going to start this direction, and my graph is going to go upward. Now, I need to look and see what it's doing between negative 2 and 0. So what's between negative 2 and 0? Negative 1. So let's do the same thing. Negative 1 plus 2, negative 1 minus 3. All I'm doing is taking my equation and putting the value in for the x. So I get negative 1, 1, negative 4. Really don't care about the answer. I do care if it's positive or negative. This case, it's a positive 4. So when x is 1, we're up here at positive 4. Hey, that works. Now, we need to figure out what it's doing between 0 and 3. I don't know about you. I don't particularly care for fractions, so I'm going to pick a different value. I don't want to plug in 1.5, although you can on your calculator plug in the exact middle. But you could plug in positive 1. So 1 plus 2, 1 minus 3. And again, I'm going back to my equation, just plugging in 1. So that's 1 times 3 times negative 2. That's a negative 6. So when I'm at 1, I'm down here at negative 6. Now, I don't know if that's the turning point. I could check 2. You don't have to. But let's make it interesting. That's 2 times 4 times negative 1. That's a negative 8. So we were at negative 6 before, so it drops down even more, negative 8, before it starts to come back up. And then over here, my graph hopefully is on the positive side. So let's check 4. 4 times 4 plus 2, 4 minus 3. That's 4 times 6 times 1. That's 24. So it's a positive. It's up here somewhere. But the key thing is we're figuring out what our graph is doing between the points. And we're figuring out what it's doing on the ends. We know where it crosses, so it's giving us this sketch. And notice, it's not exact. It's a sketch. Because I'm looking at it going, okay, it's positive between negative 2 and 0. It is negative between 0 and 3. When I talk about positive and negative, I'm talking about the y values. When it's beyond to the right of 3, it's a positive. And when it's to the left of negative 2, it's a negative. So we're just sketching it. We're getting an idea of what our graph looks like. It's not specific. I did a little bit more here than I normally would have. Please show me the values that you're actually substituting in, and then plug it into your calculator. You can skip writing this step, but I want to see this one and then the final one. So I know that you kind of checked it. Use your calculators. They are your friend for your math. All right, so let's look at another one. And again, we're going to sketch this. This is number 2. So to sketch it, we first have to find the zeros and graph them on the x-axis. So here I have, looking at my factors, I have x minus 4 equals 0, x minus 1 equals 0, x plus 1 equals 0, and x plus 2 equals 0. So x is 4, x is 1, x is negative 1, x is negative 2. Remember, you're solving a very simple equation. So we're going to plug these values. We have one at 4, a value at 1, another one at negative 1, and at negative 2. So I need to know what's going on in the graph and on the ends. So let's pick values. We need to figure out what's going on over here. I'm going to plug in negative 3. Now you have to be careful with this one because it has a negative on the outside. So negative 3 minus 4, negative 3 minus 1, negative 3 plus 1, negative 3 plus 2. So we're simply going to simplify. That's a negative, negative 7, negative 4, negative 2, negative 1. I don't want to multiply those numbers together. I know it's a big number. I want to look at my negatives. Negative times a negative is a positive, times a negative, times a positive, negative, times a negative. That's 5 negatives. That means if there's odd number of negatives, my answer is going to be negative. You can do the math. This would be 56. That means my graph starts down here. Now, let's look at what's doing between negative 2 and negative 1. So we have to use a fraction here. Negative 1 and 1/2 minus 4. Negative 1 and 1/2 minus 1. Negative 1 and 1/2 plus 1. And negative 1 and 1/2 plus 2. All right, not my favorite thing to do, but we'll suffer through it. So negative, that's negative 5.5. Negative 2.5. And again, please use your calculators. Negative 1.5 and a positive. So that's an even number. That's going to be a positive answer. I'll let you guys compute what it is. But I know between these two, it's a positive value of some sort. Okay? So compute the values. Now, let's check between negative 1 and positive 1. Going between negative 1 and positive 1 is 0. So plugging in 0 here, I get negative times 0 minus 4, 0 minus 1, 0 plus 1, and 0 plus 2. That's negative 4, negative 1, 1, 2. Well, the answer with numbers when I multiply them together is 8. But I have odd numbers, so that's a negative. That means in between here, we're at negative 8. So we're somewhere down, maybe about here. Let me do that in the blue, since all my other dots are in blue. Now, my last one, I need to plug in between the 1 and between the 4. I'm going to plug in a whole number just because it makes my life easier. You can use that 2.5 if you so wish to do so, but I'm going to plug in, let's go 3 this time. So remember, we're plugging it in for the x values. And all I really care about is if my value is going to be positive or negative. So that's a negative 1, that's a 2, that's a 4, and that's a 5. So 2 negatives means it's going to be positive, and if I actually multiply that, that would be 40. So I know it's up there somewhere sky high. Now let's look and see what it's doing after 4. So let's plug in 5. And again, we're plugging into the same equation each time. So that's a negative 1, 4, 6, 7. That's a really big number, but all I care about is its negative sign and my graph is ending down here. So we're going to, again, sketch the graph. So I know it's doing this. It's coming up at some point in time, and it's coming back down. Goes back up, comes back down, and it finishes out going that way. Arrows in the ends of your graphs. It's not precise. It goes way higher up here than I have for my graph. So it's not exact. It's just an estimate. So remember, it's a sketch. It's not a graph.